2022 or beginning of 2023, I started working on, or actually since 2016, I was working on VPP routing. And this is a kernel bypass routing. So rather than just having Linux actually do the routing in the kernel, this goes into a program in user space. It makes a routing decision there, and then it comes back and gets dropped in the network card. So it's much faster, and I have test results that are in the 250 to 300 gigabit per second on the same computer that these results are from. However, you have to do a lot of things to make that work, and that's kind of, it's a good science experiment, but it's not a good production system. And so in 2022 timeframe, a few people on the outside who are much more into this project than I am, built some of the key components that we need, or that everybody needs, to make this more stable and more production oriented. And there were a lot of bugs all through 2023, and even until the end of 2023 in those components. And so every couple of months I look back and I'm like, man, it'd be great to have that working, and it just doesn't. And so that means, okay, let's just throw it away and go back to kernel routing, right? Because one way or another, we need to have some kind of routing, and we can't wait an infinite amount of time for this program. So I've come up with an idea for a compromise, and the idea is go ahead and do Linux routing, set it up, put the network cards into a namespace, set up the route, set up the routing daemon, do all the stuff, and then start VPP. And the way VPP works is it steals the NICs from Linux. It basically takes them away so you can't see them anymore, and then it does its thing. Now, if VPP crashes, you're back to having no NICs again. So the idea is if we set up Linux and VPP to have the same exact settings, and there's a problem with VPP, just reboot the box and go back to kernel routing, right? And so the idea is we could have a safe fallback, because part of the issue I've been wrestling with is that we have to have double infrastructure for everything, and really double of VPP and double of data, so really 4x. And so this is kind of annoying. And so some time ago, I was talking with Brian, and he said, how much does Linux routing really do? And so I retested, quote unquote, the best that we can do. Not quite true, but close enough, right? And so kernel routing, I have 3 different dimensions I like to test in the lab. One is the smallest possible packets, just like a DOS attack, like massive network flood. And on a box of 22 or the 21 cores and a 30 gigabit connection, you can only get 4 gigabit through before the system latency skyrockets, and the system just literally doesn't respond, it reboots. So that's not great. That's a DOS attack, right? And then if you have really boring web traffic, you can get around 7 gigabits. Mainly this is just because it's very heavy quantity of traffic being pushed around, even though you're on a pretty big link. And then there's another type of traffic, which is like an extremely heavily mixed traffic. It's like video and call and DNS and web and small requests and big requests. It's a very complicated test. And I can get 14 down, 5 up, right? So this is kind of like, it feels like an internet bandwidth test, right? It's about around that. And this latency is actually high. All of these latencies are very high compared to a switch. But it illustrates that you really can't get 10 gig through on a Linux box just doing regular boring kernel routing, within a couple asterisks there. And you can get a little bit more if it's like mixed, but it kind of depends. And if you enable NAT, you get down from, why do I only have 1 test result, I'll tell you, but you get from 4 down to about 2. And so you kind of lose quite a bit of performance by enabling NAT. And there's some other oddities. Why don't I have these other tests yet? I didn't have a chance to, I did run them, but the test results were odd or inconclusive. And so I don't have a number that I can show you that makes sense, but it is lower than these numbers. It's just, I don't know the exact number. The other tests are all repeatable. Anyway, and I've started working on VPP again, and again with that idea that we kind of overlap them. And again, it is a challenge still, even now. Any one of us can probably download the packages and install them, but whether they work right away is a question. And there's a whole bunch of things with huge pages and different kernel bypass drivers and secure boot, and a bunch of other stuff, which just makes a big mess. So I hope to give another update in the near future. Questions? No? Cool. Thanks. Thanks.